Hi, good morning to one and all. Myself Vishnu Sai Charan. I am from Civil Engineering Department from IRE College. Today our topic is this is theory of structures, and this topic is full scale testing of two-tier steel buckling restrained braced frames. So we have to this is more one more topic, and we have to see this full scale testing of two-tier steel buckling restrained braced frames. So this is our topic. We have to introduce introduction to BRBFS. So this buckling restrained braced frames are structural systems designed to resist lateral loads. In this BRBFS, these are to use only resist lateral loads, and they provide enhanced performance during seismic events compared to traditional braced frames. And understanding this behavior through full scale testing is crucial for design and improvements. And this BRBFS is completely depending upon full scale testing mission and designing improvements. So there are so many designings in this BRBFS. Importance of full scale testing. Full scale testing allows for the observation of actual behavior under. So this understanding this behavior through full scale testing is crucial for design improvements. Importance of full scale testing. So what are the important we have to discuss. Full scale testing allows for the observation of actual behavior under real world conditions. It completely helps validate analytical models and designs and methodologies for BRBFS. And completely it should be useful to finding can lead to safer and more efficient structural designs. So these are the three more importance of a full square testing. In this testing is much more important. And second one, overview of two tier systems. So in this figure we have to observe overview slides multi-tier systems of support. So in any way we can support statewide training update by CDA. Two-tier BRFS consist of multiple levels of braces that enhance lateral stiffness and strength, and it's completely depend upon stiffness and strength. This BRBFS is more completely depending upon stiffness and strength and durability. This configuration can optimize materials to use while maintaining structural integrity. This configuration can optimize materials used while maintaining structural integration. So, it is particularly useful in high-rise buildings where lateral forces are significant. So, these are the three more points in overview of two-tier systems. Objectives of testing program. So what are the objectives and what are the importance and the useful and testings we can see. The primary objective is to access the performance of two-tier BFS under cyclic loading. So in this testing of program, it aims to evaluate the energy dissipation and ductility characteristics of the frames. And one more goal is also there. Another goal is to identify potential failure modes and improve design codes. So this testing is to improve the codes, designing codes. There are so many number of designing codes are there, so we can utilize. Test to setup and methodology. So what are the tests and what are the methodologies we can. The test to setup includes a full scale frame subjected to lateral cyclic loads. In this test up methodology, the type includes a full scale from subjected to lateral cyclic load. Instrumentation is used to monitor displacement and strain and failure progress. A systematic approach is employed to ensure repeatability and reliability of data. So this test up methodologies in this test that includes a full number of scale frames is subjected to lateral cyclic loads. There are interlinking between the full scale frame and lateral cyclic loads. And this instrumentation is used to monitor displacement, strain and failure progress. This instrument is used to monitor displacement monitor and failure progresses. A systematic approach is employed to ensure repeatability and reliability of data. Specimen design and materials. What are the specimen and designs and materials? Are the specimen and design according to current and engineering standards and codes. And high strength steel is typically used for braces and connections to enhance performance. And these materials properties are verified through laboratory testing prior to the full scale tests. So in this specimen designed materials, so these are according to current engineering standards and codes. So in these materials and designs are engineering purpose only we can use, and high strength steel is typically used for braces and some connections are to more performance. And these materials are properties are verified through laboratory testing purpose prior to full scale tests. So these are utilizing some more steel structures. Loading protocols. So what type of loadings? So loads are there are so many types in this. How we can apply, we can imagine. The loading protocols are designed to simulate seismic conditions experienced by buildings. Cyclic loading follows to established standards to evaluate the behavior of the frames. Variations in loading speed and amplitude helps access different performance aspects. The loading protocols are designed to simulate seismic conditions are to experienced by the buildings. To cyclic loading follows to established standards to evaluate the behavior of the frames. And to variations in loading speed and amplitude helps access in different performance aspects. Some data collection techniques are there. So what are the we can do? Advanced sensors are employed to collect data on deformation and stresses throughout testing. So in this you have to observe that data collection techniques. So in this figure we can observe techniques are there, description tools. In this using secondary data, using that already being collected by others, this data is collected by another data. So tools, what are the tools? Checklist, data completion forms. So second one, observing. So the system selecting, watching and recording behavior and characteristics of people to objects or events. Events are high data complements and to improve on interviewing. These are overall questioning of responsible either individually or group member. As your choice, we can do anything. Interview guide. Some tools are there. Also two types: interview guide, data complication forms, and these conducting focus groups. These faculties free discussions on specific topics which were selected from the participants. Flip charts. So high speed cameras and lasers are displacements to provide precise measurements. Data is continuously recorded for lateral analysis and evaluation. So these are the data collection techniques we have to observe. Observe structural behavior. So initial testing indicates significant energy displacement capability in two-tier BRFS. The frames of demonstrate excellent ductility, allowing for large deformation without failure. Observing and reveal that brace bulking occurs at higher load levels than anticipated. Performance under cyclic loading. The cyclic loading testing minimal residual deformation after unloading. Two-tiered conformation exhibit improved stability and to compare to traditional single-tier frames. The testing confirms the frame's ability and to sustain repeated loading without significant degradation. Failure mode identified. Common failures includes brace bulking. Some connections are there, some failures are there. Understanding these modes contribute to enhance further designs and codes. Comparison with analytical models resulting from full screen tests are compared against predictions from analytical models, and this comparison is critical for validating design methodologies used in practice. Implementation of designing codes. Some codes are there, engineering codes. We have to find out the testing programs can influence updated to design codes for BRBFS. Code updates may include reviewed re-equipments for two-tier braced frame designs. Future research designs directions. Further research is needed to explore the behavior of BRBFS under varying conditions. Long-term performance studies with helps durability and survivability. Industry applications. Two-tier BRBFS are suitable for high-rise buildings and structurals in seismic zones. Some particular zones are there, so we can utilize. Then these performance characteristics makes them a reliable choice for modern architecture. Case studies of implementation. Several high-profile buildings have successful ingredient two-tiered BRFS systems. So in this lesson, learned from this implementation in from ongoing research and development. Challenges implementation. Despite their advantages, there are challenges related to fabrication and installation. Addressing these challenges is essential for wider adoptions in the industry. So summary of key findings. The full-scale test validating the enhancer to perform their BF. The study contributes value for the structural engineering. Conclusion. Full-scale testing of two-tier BF is essential to advancing of structural designings. The insights gained pave the way of safer and more resilient buildings. Ongoing research will you understand and applications of these systems. Okay, thank you.